In lesson 7D, we're going to look at infinite geometric series. Infinite series are series whose patterns never end, and they will usually be denoted either by an infinity symbol or with a dot 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 at the end. For example, 1, 2, 4, 8, 16 plus dot dot dot. You know this is geometric because if you pull the ratio 2 over 1, 4 over 2, 8 over 4, all have a ratio of 2. But this one doesn't end, and you know that because you have the dot dot dot. The second example, 100, 50, 25, 12.5, 6.25, they all have a common ratio of a half, and then you've got the dot 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 at the end. If your R value is between -1 and 1, notice I said between and not including. There is not an equal sign there. If it's equal, it won't work. If your R value is between -1 and 1, then despite the fact that the series is infinite, you're still able to find the sum. And you're thinking, well, if you keep adding numbers, that's going to keep changing the sum. But as long as your R value is between -1 and 1, as you head out to infinity, the amount that you add becomes so small that it's insignificant. And that's why you're able to come up with a sum for that. So we have a different formula. S equals a sub 1 over 1 minus r. Notice your S here does not have an n. It's not like you're finding the sum of a certain number of terms, so it's just a blanket S. A sub 1 is the value of the first term, and your r is your ratio. Now this only works if r is between -1 and 1, and so that's the first thing you need to check. Alright, so let's look at an example. It asks us to find the sum of the series 1/2 plus 1/4 plus 1/8 plus 1/16. So before we even write down the formula, you need to check what that R value is. So we're going to check our R value. And so we know R is 1/4 over 1/2, which is 1/4 times 2 over 1, which simplifies to 1/2. And then you could do an 1/8 over 1/4, and you're going to get the same thing. So is 1/2 between -1 and 1? And it is. So we've satisfied the requirement for using the formula, so we're going to go on and use the formula. So S equals a sub 1 over 1 minus r. A sub 1 is 1/2. And then you've got 1 minus the r value of 1/2. So this is going to be 1/2 over 1/2, which is 1. So if you took your calculator and you said 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1 over 128, and you kept going, your number is going to get closer and closer and closer to the value of 1. When I say your number, I'm talking about the total amount. Alright, so that worked on the first example. Let's look here. Find the sum of 4 plus 12/5 plus 36/25. Alright, so first let's check our R value. So we're going to take the second number, 12/5, divided by 4. That's the same thing as 12/5 times 1/4. So we got 3/5. If you want to check it with the next one, you got 36 over 25 over 12 over 5. So that's 36 over 25, because you still want to make sure you have a common R. Multiplied by the reciprocal, 12 goes into 36 3 times. 5 goes into 25 5 times. So yep, we have that common R value, and the R is 3/5, which 3/5 is between -1 and 1. So that checks out. So we're going to go on and use our formula. S equals a sub 1 over 1 minus r. A sub 1 is 4. R is 3/5. So we have 4 over 2/5, which is 4 times 5/2, which is going to be 10. So when we go to find the sum of this infinite series, we would say the sum is going to be 10. All right, let's look here. We have an infinite series, got the dot, dot, dot. So r equals 5/2 over 3. So that's 5/2 times 1/3, which is 5/6. All right. So our sum is going to be a sub 1 over 1 minus r. Okay, the value of a sub 1 is 3. R is 5/6, so 1 minus r is 1/6. And so that's going to give you 18. Now, what you do want to be careful of is when your r value is negative, which is possible, that you plug it in appropriately and you do 1 minus a negative, which means you would actually be adding in the denominator. So you want to make sure you follow the example to a T. All right. We talked about in the last unit the sigma notation. When you're doing infinite geometric, your upper isn't going to have a number there. It's not going to have the ending value for the last number you should plug in. It's going to have the infinity symbol. And so that denotes a dot, dot, dot should be written at the end of the series. So everything else is pretty much the same. So when you're looking at this, you probably should expand this out. So we have -6, 3/2. If we plug 1 in, we're going to get to the 0 power, plus -6, 3/2. Plug 2 in, you get a 1 there. Okay, plus -6, 3/2 squared. And of course, you'll show this with the dot, dot, dot. So if you were asked to expand this sigma notation, this would be your first step. Anything to the 0 power is 1, so we're going to have -6. And then if you clean this up, you're going to have -9. And then if you clean this up, you're going to have 54 over 4, which is going to be 27/2. And you would say dot, dot, dot. And then what's going to happen is you test this out, you get your r value is 3/2. Now your r value is always the piece in parentheses that belongs to the exponent. So I didn't have to expand this out to see the r value. I could tell that from the sigma notation. But expanding it out helps you see and kind of test that theory. Now, we figured out what your r value is. It's 3/2 fall between -1 and 1. Because in order for us to continue, that has to be true. And this is not true. So if you can't meet that requirement, then you're not going to be able to find the sum. And we just say no sum. And if it asks you to explain why, you say because r is not between -1 and 1. All right, I'm going to change this so that we can actually move forward here. Let's do this. Let's make that a 1/3, because otherwise this one wouldn't work either. All right, so if we were asked, this is 1/3 is what belongs to the exponent, so that's going to be our r, which 1/3 does fall between -1. We don't want it to be equal. Between -1 and 1. So we can move on with our formula. S equals a sub 1 over 1 minus r. A sub 1, if you plug 1, your first term is going to be when you plug 0 into that. So we have 5/6. A sub 1 isn't just plugging 1 in, it's the value of the first term. And the way this sigma notation is written is our first term comes from plugging in 0 in for I. All right, so this goes to 1, so our first term is going to be 5/6. So we have 5/6 over 2/3. All right, so 5/6 times 3/2. means that we are going to have a sum of 5/4. Okay, so infinite geometric series are nice because it helps you be able to find the sum of something that you wouldn't normally think that you could work with. But it does have some strict regulations, and you got to make sure you satisfy those before you start trying to plug things into the formula. All right, so if you would, go ahead and try the activity for lesson 7D, and let's see how you do with it.